Hello guys and girls, Raj here, back with another design video. In this whiteboarding video, we will design Twitter. Now this is an interesting one because a couple years back, Twitter actually published their internal design. So if you get this question in your whiteboarding interview, chances are your interviewer have watched that video. So in this video, I'm gonna go over what Twitter has disclosed and how the design look like, but we are also gonna discuss some of the areas that you should expect questions from your interviewer. Like interviewer might say, you did this because the interviewer knows that you also have watched this video or the Twitter's design video. So the interviewer will intentionally challenge you in couple areas. So we'll go through those. And we are gonna talk about AWS services to implement the design. So as always, this video will serve as a general system design video as well as AWS system design interview video. All right, with that, let's get started. So when you get any design challenge in an interview, you should not jump into the design. I say this in all my whiteboarding video. So you should write down the features that you want to design in the interview. So in this case, we are going to cover the features of tweeting, retweeting, the timeline that you see in your Twitter feed, the trending feature, and the design specifications that this design need to follow is the design should be scalable because Twitter is of massive scale. Millions of users use it. The design should be highly available and it should be secure. So the security part Twitter did not cover. So I'm adding that part here and we're going to discuss how to make the design secure. So now let's take a look at a scenario where a person has multiple followers and such. So let's say Tina is a person of interest and Tina has 3 followers, Bob, Joe, and Mike. Now Bob also has 1 follower, Kim. So let's talk about how will the database tables look like, and then we'll dive into the design. Okay. So the user and the follower table will look like this. One column will have the name of the person and then the other column will have the name of the follower. So if I want to represent this follower pattern, the table will look something like this. So the person, Tina, have 3 followers. So for Tina, you will have 3 rows. One row will have follower Bob, follower Joe, follower Mike. But then Bob will have another row as well, right? Because Bob also has 1 follower, Kim. So in this case, the person will be Bob and follower will be Kim. So you might think that, Raj, why don't we take a table where the person will be just Tina and the follower can be string, and you are gonna concat all the names of the followers for that person in 1 row. So theoretically, it sounds like a good idea because then you will reduce the number of rows. But the problem with that is if you put all the name of the follower in 1 row rather than multiple rows, you cannot really put an index on that column. So if you need to find out who this person follow, you need to parse the string, parse it, and the program needs to do a lot of if-else logic, which is not optimal. But if you create separate rows, you can create index on the person and the follower, and then it's faster to query. So now let's take a look at the tweet table. So the tweet table will look something like this. So this is the column person. So this will have the values from this table, then the actual tweet, and then a date time field. So let's say Tina tweets something. So how will it look like? Okay, so let's say Tina tweets, "I love cake." Okay, so this table will have an entry. The person row will have the value Tina. The tweet will have the actual tweet, and the date time will be like the timestamp of the tweet. In this case, it's like 2021, June 10th, 10 o'clock. Doesn't matter. So at this point, you know which followers should be notified or which followers' timeline should be changed to reflect this new tweet from Tina. So if we join these two tables, right? So this table has the name of the person, and then we can use this value to join with this table, get all the name of the followers. Then you know which followers' timeline should be changed. So this is where the first design decision comes in. How should you create the timeline for the followers? So you have two options. One is, so every time Bob, Joe, or Mike logs in, and when they log in and go to their timeline, the application joins these tables and then grab all the tweets from all the Bob's followers, Joe's followers, Mike's followers, and create their timeline. So now the problem with this approach is Twitter is a read-heavy application. So you read tweets way more than you write tweet. At this approach, since you read more, the application need to query this table way more times, right? Because when you log into Twitter and trying to read your timeline, that's when all these queries will be executed. So statistically, this query will be executed way more times. Second, if a lot of users starts to log in at the same time, the application needs to scale massively, and you will discover slowness in your timeline. Because remember, your timeline is being created as each user is checking their Twitter at that point of time. So instead, the design principle that Twitter adopted, and they disclosed it as well, is they create the timeline for the followers when the person tweets. So they create it when someone writes something. So as soon as Tina writes or tweets, "I love cake," they're gonna go create the timeline for Tina's followers. So to them, statistically, it is less intensive to do this during write than to do this during read. However, they optimize this process by taking some ideas from the previous principle. So the previous principle is you load the timeline when each person logs into the Twitter. So in that way, only the person who are logging in will trigger loading and creating the timeline and querying all this table. Whereas if Tina tweets and you just blindly create the timeline for all these followers, it may be the case that some follower may never log in and you just spent your application CPU for creating their timeline and it goes to waste. So what Twitter does is, as soon as Tina tweets, instead of creating timeline of all Tina's followers, it checks which followers are active. So it will only go and query the tables and create the timeline for the users who have been active in, let's say, last 10 hours. So now let's talk about the actual database and how the system is designed. So I'm going to wipe this table for now. So as soon as Tina tweets, so basically when you tweet, it's an API. So you post some tweet using API, and for this design, we are going to use API Gateway. So the API gets invoked. So now we come to our next design decision, whether to do this synchronously or asynchronously. So synchronously as in, this API will wait till the backend processes it. So one example could be this API is calling a backend EC2 or a Lambda, and then it goes to the database, processes it, and then returns it. But if you think about it, for a high-scale design, it is not ideal. Because when a lot of people are tweeting at the same time, all these components, this API gateway, EC2, and then if we have a database, we are going to talk about the database in a little bit, they all need to scale at the same time and at the same rate. And sometimes your database can only handle up to a certain number of connections. So if this database fails to scale, the whole chain fails. And the problem with synchronous design is there is no retry built in. So if this tweet fails this whole chain, this person's tweet is not gonna get posted. Only way to retry is the person Tina needs to tweet the same thing again. So how these designs are handled is by breaking it into a synchronous design. So by asynchronous design, I mean instead of API gateway calling the application within the same connection, this API gateway will simply put the tweets into some kind of queue. Okay, so this API gateway will put the tweets in SQS, a simple queue service, so the front end can scale, right? So millions of users can start tweeting at a particular moment, and this API gateway can scale and put all the messages into this SQS. Now the messages will be processed by application running in a virtual machine, in this case EC2, and you can control the rate of consumption based on the database capacity. And even if a message fails to get processed by this EC2, the message will simply be returned back to SQS, and the EC2 will try that again. So this is why the retries are built in, and this is much more scalable than your traditional synchronous design. So how do you make this backend scalable based on the number of messages? So EC2 can stay in an auto-scaling group, and in scaling configuration you can mention that scale the number of EC2s based on the messages present in the SQS queue. So I'm going to put this EC2 in an auto-scaling group. So I put ASG as an auto-scaling group. All right, so now back to the database discussion. So in this database, we have the tables that we described, right? The tweet tables and the person follower tables. So actually Twitter said what database they use and the reason. So let's go over that, and then I'm gonna go over a couple of questions you might get from your interviewer. So Twitter said that the responsiveness for when the user checks their timeline is super important to Twitter. They don't want the users to just wait there when their timeline loads. So that's one of the reasons how they pre-compute the timeline, and for the same reason, they selected a memory-based caching database named Redis as their database. So Redis is not a disk-based database like your traditional MySQL or Aurora. Redis is memory-based. It's a cache database, and because it is memory-based, it's super fast. So how Twitter implements this is they create the same copy of those timeline 3 times to make it highly available. Okay, so as you can see, there's 3 copies of the same table. Because Redis is a memory-based database, so it is not really durable like your RAM or memory in your desktop or laptop. So whatever is saved in the memory, if your laptop crashes or you restart, those data is gone. So that's why Twitter saves the timelines, the same one timeline for one follower, into multiple Redis databases. So in this case, 3 copies to make it highly available. So what is the con of this? So they did not cover this in their video, and you might get this in your interview. So one disadvantage of this is Redis is fast, but it is expensive. So as your user grows, because you pay more for your memory than you pay for your hard disk, the cost of the database goes up way higher. So you might get this question that, hey, Mr. Candidate, what other database can you replace this Redis with? Traditional relational databases is not a good fit for this because traditional relational databases cannot scale massively when the need arises. And also they are expensive. So you need a database which can scale really fast and which has a low response time, and also it is cost effective. So you can use DynamoDB here because DynamoDB saves one copy of the data in multiple availability zone, making it automatically highly available. It has millisecond range response time and it scales massively, and it is also pay as you go in on-demand mode. Also, you can tell the interviewer that if we need even faster response, less than a millisecond and in the microsecond range, we can use DynamoDB Accelerator or DAX for this design. So to summarize, Tina tweets, the tweets gets processed by this queue and the auto-scalable virtual machines running the application, and this application creates the timeline for all the Tina's followers. In this case, Bob, Joe, and Mike, and then it inserts into this Redis database. So for Bob, it will have the timeline for Bob ready, taken from all the person or all the people that Bob follows, and it will order it based on the timestamp. So as soon as Bob logs in, checks the Twitter timeline, he can see the timeline right then. Okay, so this is how you do the tweet functionality. Retweeting is very simple. So if Bob also likes what Tina said, Bob can retweet. So what it does is when Bob retweets, it can use this same API and puts the tweet back into the queue. And then in this case, Bob's followers timeline will be pre-computed and gets loaded into this Redis database. Now there is a challenge to this. So let's say Bob, Joe, and Mike are also following someone very famous. Bob, Joe, Mike follows Elon Musk, and Elon Musk has millions of followers, right? So outside of Bob, Joe, Mike. So if anytime Elon Musk tweets and Twitter needs to recompute the timeline for all of Elon Musk's followers, it's a huge challenge. So that's a lot of CPU that you need to spend. So the way Twitter circumvents this is they only pre-compute the timeline for the person who doesn't have a huge following. So they say, oh, Tina has only, let's say, 1,000 followers. So if Tina tweets something, I will pre-compute that for Tina's followers. But if Elon Musk, who has, let's say, more than 1,000 followers, tweets something, I am not going to pre-compute for all the Elon Musk's followers. So at this point, Tina tweeted something and Bob's timeline is pre-computed with all the tweets from all the people that Bob follows, but those people have, let's say, less than 1,000 followers. And when Bob logs into the Twitter checks if Bob follows someone famous and if that famous person tweeted something in less than 24 hours. If the famous person has tweeted something in less than 24 hours, real time it fetches those tweets and inserts into Bob's timeline based on the timestamp. So as you can see, Twitter takes this hybrid approach, pre-compute plus inserting some tweets real time based on the number of followers. So now let's talk about trending. So trending is sometimes you will log into Twitter and you will see on the right side that some stuff is trending, like hashtag Bitcoin rules or hashtag we love Elon Musk, something like that. So how does Twitter do this? So there are two ways to achieve this. So one way is as the tweets are getting saved in the database, you can run another process to see the hashtags associated with the tweet, and you query the tables and see what hashtag has most number of tweets in the last 1 hour in a particular country, and then display that. But the problem with that is we get millions of tweets like every hour. That will heavily stress this database. So Twitter actually has a separate workflow for this. Once they get the tweets with some hashtag, they actually put it in a streaming architecture. So in this case, let's say we're going to put the tweets in Kinesis. So this VM puts the tweets into this Kinesis data stream, and Kinesis data stream puts into Kinesis data analytics. So Kinesis data analytics lets you query on the stream real time. So in this Kinesis data analytics, in the stream of tweets, you can run SQL, and this SQL gives you which hashtags have the maximum amount of mentions, and with that, you can go populate the front end. Another advantage of this is using Kinesis data stream. You can send it to Kinesis data firehose and save all the tweets and archive all the old tweets in S3. So data streams sends those tweets to data firehose, and then that saves it to S3, and using S3 lifecycle, you can archive the tweets. So how do you make this design secure? So when it comes to security, there are 3 aspects to it. One is the authentication and the authorization piece, like only the users who are authorized will be able to tweet or read tweets. Number 2, the security of the data. So the security of the data in transit and security of the data at rest. So let's tackle the authentication and authorization piece. So when you register in Twitter, what happens is your username and password get saved in an identity provider, such as Active Directory, Okta, Auth0, or Cognito. So in this case, let's go ahead with the cloud native one, Cognito. So Cognito is AWS's identity provider service. So the user ID password is saved in Cognito. So Tina is a registered user in Cognito, and before Tina tweets, she needs to log in. So what happens is Tina passes her user ID and password to Cognito. So I'm just gonna say user and PWD as in password, and Cognito gives Tina a authentication token, or like a JSON web token. So JWT, and when Tina calls the Twitter API hosted on API Gateway, Tina passes that JWT token on the header of the API. And once API Gateway receives it, since API Gateway and Cognito are both AWS services, API Gateway can go and validate that against Cognito. So in this case, we are using Cognito user pool, and it's super fast. So this way, users are authenticated. Same thing for Bob, Joe, Mike, even Elon Musk, he also needs to authenticate. Now, when it comes to security of the data at rest and in transit, for at rest, we have to use an encryption key. So for the AWS service, for that is AWS KMS, or a key management service. So all the services that storing data at rest, such as SQS, Redis, and if there is a disk attached to this EC2, which is EBS, Kinesis, S3, all of this supports KMS. So I'm just going to put KMS on the services that supports that can encrypt data at rest. Okay, so this is how data at rest is encrypted. Now when it comes to data in transit encryption, that is done using HTTPS or TLS protocol. So all this communication between all these services are HTTPS protocol. And on API Gateway, you don't need to go super deep on it because that's like a separate conversation by itself. But API Gateway supports a mutual TLS. So not only client has to authenticate with server, server also needs to authenticate with client. So I have a separate video on how API Gateway achieves mutual TLS. So I'm gonna put a link to that up top so you can refer to that. So alright, so this is how you secure this whole design. Okay, so we covered tweeting, retweeting, timeline, trending. And for the design, we made the design scalable, highly available, and secure. Alright guys and girls, that's the video. If you learned something new, please click that like button, smash it if that's something you are into. Each like helps YouTube algorithm to recommend this video to other users. Also, please click subscribe if you are a new viewer of my channel. I make the system design video as well as deep dive videos on interviews, Kubernetes, DevOps, cloud, etc. And also let me know in the comment section if you have any question on this design or what kind of videos you want me to make, etc. Alright guys and girls, that's it for this video. I will see you in the next one. Bye.